To conclude this routing module, I now want to go into an advanced topic which can really improve your bigger applications. Consider our application here. It's very simple, but there's one thing we can notice. Right now, if we never click on user, all the code behind this link, so all the components we created for that and so on, will never be loaded. We won't use them at all. So it might be unnecessary to load them at the beginning of the application. Now, it does of course not matter for our tiny application here, but for a bigger application with lots of code and lots of different features, this might really make a difference. If you're using a setup like we do with Webpack, where we bundle everything together into one file, then this has the disadvantage that whilst limiting the number of HTTP requests you send, you might limit it too much because your bundle therefore is really big. So you want to find the right balance in having a big all-in-one bundle and loading stuff you only need at certain points of time only at these points of time. With Webpack, we can actually do this, and you may simply Google for lazy loading plus your preferred build system if you want to find out how to set it up there. But Webpack is pretty common, pretty popular, so I will show it with this. So I already said it, it's called lazy loading what I'm talking about. Lazy loading means we only load parts of the application when we need it. So back to our routing file, how can we prepare this for lazy loading? Right now, everything is loaded eagerly, which means all the time, because we added import statements at the top, and everything which you import at the top will always be included in the bundle, no matter if you use it or not. So we have to transfer these import statements here into another syntax. So I will get rid of them. I will always import home and header, but now I want to lazily load the other 4 imports. The syntax now might look a bit strange, but it's something you really just have to keep in mind. It's a syntax Webpack will recognize, will therefore not include it into the initial bundle, but instead will create several other bundles. The syntax I'm talking about looks like this. We create a constant user to also fit the name we use down there so that we don't have to adjust our code down there. And then user simply is an ES6 function where we pass resolve as a callback in there, as a function in there. And in this function, we then want to call require ensure. And now this is really just some code Webpack will be able to execute and to recognize. So require ensure, and this now takes an array. And in this array, we set up the path to the component we want to load. So /components/user and then user.view. So like before in the import statement, now nested in there. This is the first argument, this array. The second argument is another function where in the body of this function, we use the resolve function we passed in as an argument to call require components user.view again. Now this might look strange. What's happening here? It's some syntax Webpack recognizes, and it basically tells Webpack whenever we want to load something which lives in this place, components user.view, and we do want to load it, for example, once we visit the route using our user component here. So whenever we do this, execute this function here, which is basically like a promise, which means it resolves the path you should then really use. Now, if we would have just require like this at the top, then Webpack would see this in the same way it sees this import syntax, it's just a different syntax, and would immediately load the file. But by having it in this asynchronous function here, which has to resolve before it gets executed, Webpack is only doing this if we actually need that file, and it will create appropriate bundles to be loaded at this point of time during the build process, so that everything will work smoothly without us editing anything here. So with that, I can now copy this, and yes, this arguably gets longer, but it's worth it to save performance in bigger applications. For user start, for example, then for user added, and also for user detail, like this. And now if we save this and we reload the application, we see it still works. This looks good, but how can we tell if something changed? Well, let's open the developer tools and go to the network tab here. If we go there and reload the application, you see a couple of files are loaded, most importantly our build file, which is really big because it includes all the warnings, all the source maps, everything, and is not minified at all, so don't be worried about that. Now let me clear this network tab, and if I now click on user, you see there were 2 new bundles downloaded, very small each. If I click on the individual user, a new bundle was downloaded, and if I click on added user, yet another bundle was downloaded. I think you're seeing the theme here. These are the extra bundles Webpack created because all these routes here, we set up here, are now loaded lazily. And this is how we can utilize this feature to make sure that in bigger applications, we only load parts of the application when we need it. As a side note, if you want to group certain pieces together into one sub-bundle, like that, we don't want to have 4 user bundles, we want to store it in one extra bundle, you can group them by passing an additional argument here to our require ensure function. So besides the array and this callback here, we then also have a third argument, which is the group name. For example, user. Now, if we pass that to all our user-related routes we set up here, or the component imports, if we do this, and then let's go back to our home page first, clear the console, click user, we load forward build, but now you see we're not fetching any other files. It stays at this one file, which of course now also is bigger, because this file now includes all our user-related files or pieces, but that might make sense. Maybe you don't want to have a separate bundle for every component, but you just want to group them together. And with that, you can do that using lazy loading and really therefore optimizing your application.